The equation we are given involves an x squared term, an x term, and a number term. This is referred to as a quadratic equation, and to solve it, we can use the quadratic formula, which is on page 20 of our formula book. It says that the roots of the quadratic ax squared plus bx plus c equal to 0 are x is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. To use this formula, we should begin by identifying the values of a, b, and c. A is the number in front of the x squared, and here a is equal to 2. B is equal to the number in front of the x, and here b is equal to minus 7. C is the number by itself, and in our equation we'll have c equal to minus 3. Now let's sub these values into our formula. Let's simplify a bit. Minus 7 is plus 7, minus 7 squared is 49, and minus 4 times 2 times minus 3 is plus 24. In the denominator, 2 by 2 is just 4. We can simplify further by adding the numbers under the square root. 49 plus 24 is 73. So, how do we deal with this plus minus sign? Well, this means we should split into two cases. In the first case, we replace this symbol with a plus, and in the second case, we replace this symbol with a minus. From here, it's just going to be some calculator work and some rounding. Using our calculator, the first expression comes out as 3.886001. Since we are asked to give our answers correct to 2 decimal places, we can round this off to 3.89. Using our calculator, the second answer comes out as minus 0.386001. Rounding to 2 decimal places gives us minus 0.39. We can solve these simultaneous equations using elimination. The strategy is to make one of the numbers match, but with different signs. Here, I'll focus on the numbers in front of our b term. In our first equation, the number in front of the b is plus 3. So what we'll want in the second equation is the same number, 3, but the different sign, so minus 3. So we want a minus 3 in front of the b in the second equation. This can be obtained if we multiply across our second equation by minus 3. 5a times minus 3 is minus 15a, plus b times minus 3 is minus 3b, and minus 8 times minus 3 is plus 24. We now have the match on the b term that we wanted. We've the same number, 3, but different signs. The next step will be to add our equations together. 2a minus 15a is minus 13a. The plus 3b and the minus 3b cancel each other off and give us 0. And 15 plus 24 is 39. So now we have an equation in A, minus 13a equals 39. To find A, we'll need to get rid of this minus 13. This is being multiplied by the A, so to get rid of it, we should do the inverse operation to both sides. In other words, we should divide both sides by minus 13. performing the calculation on the right hand side gives us an answer of a is equal to -3. We're not done yet. We were asked for the value of b as well as the value of a. To find this, we can take one of our original equations and substitute in the value of a we found. Here, I'm going to take the first equation, 2a plus 3b equals 15. We found that a is -3, so we can sub this in. 2 times -3 is -6, so we get -6 plus 3b is 15. The goal is to find what b is, in other words, to get b all by itself on one side of the equation. To do this, we'll want to get rid of the -6 and the 3. The -6 represents subtraction, so to get rid of it, we do the opposite, addition. So here, we'll add 6 to both sides. We can simplify the right-hand side here. 15 plus 6 is 21. The 3 in front of the b represents multiplication, so to get rid of it, we do the opposite, which is division. So here, we'll divide both sides by 3. 21 divided by 3 is 7, so we get our answer that b is equal to 7.